again, this is all very new stuff. 802.21 is a standard on media independent handover, and this has actually become a standard now this year or last year actually. So it's little bit more solid. So in this lecture we'll talk about the types of handovers, then what does 802.21 do, and its services and the protocol. Alright, so first of all, handover means going from one tower to the next. And when you are driving and on the cell phone, you are probably handing over, or you are being handed over many times. Right? And generally these handovers are what we call make before break. So you are talking to the old tower, you talk to the new tower, in between you talk to both towers for some time, and that's why you don't see a break at all. You don't even notice that you have been handed over. In many situations that is not possible, and if that is not possible, then you will have to break up the connection and go to the new connection, and that is called break before make. Right? It's known as soft handover, and this is known as hard handover. Hard handover means that you break, there is a break. Soft means there is no break. And for that you might need two radios, or you need at least to be able to listen to two different radios. Yeah. So that is the desired handover anyway. And then we have horizontal and vertical. Horizontal means the same technology, and by the way the word RAT is used for the technology. RAT is radio access technology. So for example, WiMAX is one RAT. 802.11 is another RAT. 3G is third RAT. So these are all radio access technologies. If you stay in one technology, for example, if you move from 802.11 to 802.11, that would be called a horizontal move, horizontal handover. Right? But if you move from one technology to another technology, such as if you have an 11 connection and you move to WiMAX connection, that would be called a vertical handover. Alright? So vertical handover is different RATs, whereas horizontal handover is the same RAT. Okay? So actually before MIH it was not possible to do vertical handovers. So every technology, for example, 11 defines how you go from one access point to the next access point. WiMAX defines how do you go from one base station to the next base station. 3G defines how do you go from a cell tower to a cell tower, right? But you could not go from a cell tower to WiMAX or from WiMAX to 11. Right? Because they didn't talk to each other. So the media independent handover, this particular standard, 802.21, is designed exactly for that. Is that you can go from, if you had a Wi-Fi connection here and you walk out of the building, Wi-Fi is not there, but WiMAX is there, you should be able to continue. Right? So that's the function of this this standard is media independent handover is for vertical handovers. Alright, so who starts the handover? First of all, who controls it and who initiates it. So it could be terminal controlled and terminal initiated, or network controlled and network initiated. So there are two controllers, the base station and yourself. One of the two may recognize that you need to change, and so if the control is under the terminal, that is terminal controlled. If it is initiated by the terminal, that is terminal initiated, and the network will help, or network initiated and the network totally controlled as well. So these are the three different possibilities. Most of these actually are terminal initiated and network assisted, the middle one. Because the terminal is the first one to notice that I am not able to listen to the base station, I am not able to get the tower, and first thing, Second thing, it also is the first to know that I am getting a better signal from tower number 2. Right? So based upon that, it says, okay, I want to move to tower number 2, so that is terminal initiated. Right? And then something has to be done between tower 1 and 2 so that you don't get disconnected, so that is the network assisted part. Okay? Alright, so on this slide we introduce a new term called RAT, and we will be using it quite often. In fact, from now on that we defined it. And second thing is we understand the vertical handover. Right? So this whole lecture is about vertical handovers. Now, horizontal handovers are already defined. So 802.11i defines pre-authentication. Pre-authentication means that before you join a access point, you could be authenticated already. So that way you could, so that is defined in 11i. 11r defines fast BSS transition, where you can go from one basic service set to another basic service set using that standard, changing again the access point. 16E has similarly the handover process optimization. AF defines the port access control, and port access control is that if you connect from one point on the Ethernet port on the wall and go to another Ethernet port on the wall, that is 802.1 AF standard will allow, you know, all that. So these are already defined. These are not what we are going to talk about here because they are horizontal handovers, right? These are in the same technology. And all of them basically reduce the handover time by pre-authentication, which means that when you move to the next point, you already known that, you know, what your name is, what account number you have to be charged and all that. So that way they don't waste time. As soon as you get connected, you can start communication. All right. So authentication time is the main thing that is being optimized. So about this one, we have to start seeing the deployments now. And this started in 2004, became a standard in 2008, and we are starting to see the deployment now. And much of the deployment actually is in the CPEs. That means in your laptop or in your phone, or in the devices that have multiple interfaces. So how does 802.21 help? First of all, it tells you what technologies are available beforehand, so you don't waste your time trying to find them. So my computer, for example, right now, this computer has 11 and 16. Right? It also has 15, by the way, the Bluetooth. So it has 3 radios in this one. Right? My cell phone has Bluetooth, 11, and 3G. It has 3 technologies in it too. Right? So the point is that they could be scanning all the time as to what is available and what is not available, and one way is for the user to just turn off the radios. For example, in my computer I have turned off the WiMAX because I know there is no WiMAX in this area. But it could also be using that geo database we were talking about before, or some other database. 802.21 has the technology for you to be able to interrogate or ask a database whether there is a WiMAX available here, and if it is available, then you can start scanning for it. All right. So that is first function. It can reduce power consumption by avoiding unnecessary scanning and using the information that is available in the databases. Okay. Second thing is It can also use the core network. So for example, I have a Ethernet port here which could be connected, and that could be used to find out whether WiMAX is available or not. So you could get the information by wired methods rather than wireless methods. You could reduce the handover time by passing the security information to the next point of service, and that's the key, is that while each standard has a technology for handover among itself, now with this one we are able to go to two standards. So if you want to move from 11 to 16, you can pass on your authentication and other stuff from 11 to 16. So that's what 21 does, and we will see as to how it does that basically in a minute. So that is by passing, and then allows service provider to enforce their policies and roaming agreements. So what is a roaming agreement? Roaming agreement has to do with who can use the network when they are outside of their base area, right? So suppose you have St. Louis phone number and you go to San Jose. San Jose has some other cellular companies. Whether your cell phone will work or not will depend upon whether the two cell phone companies have a roaming agreement and that you have subscribed for roaming as well. So two things. First of all, if a good example, if you go to another country. So for example, if you are an AT&T customer here and you go to some other country where there is, AT&T is not there obviously, but some other company is there, and your cell phone will still work if AT&T has a what agreement? Roaming agreement, and that you have paid AT&T for that roaming because it costs AT&T some money and it will cost you a lot more. So those are the two requirements. So those things have to be enforced before 802.21 will let you move, because if it lets you move without those enforcements, you might end up with a big bill without realizing that you never signed up for it. Right? So those things are all done by 802.21. All right. So how does it do it? Let's see. Well, it will come in a minute, but so the mechanism is going to come in a minute. So let's keep on continue with the features. So first feature is it allows network selection. So you can select between 3, 11, 16, 3G and 3GPP2. Everybody knows what is 3G, right? I think we talked about that. Third generation telephone, right? Third generation cellular networks. Then the mobile subscriber, MS, can automatically connect to the right network by observing the user selection policies. So the policies are built in. So for example, in this cell phone, Apple has made the policy. Actually, I don't think I made the policy, or I don't know whether I can change the policy. So the Apple's policy is if Wi-Fi is available, then it will use Wi-Fi and not 3G. Why? Because 3G is very limited bandwidth, 3G is expensive, Wi-Fi is free and lot of bandwidth. So that policy is built into this phone, iPhone. Similar policies can be made that if I have Ethernet available, then I don't want to use Wi-Fi because Ethernet is much higher speed than Wi-Fi. And actually that is also built into the Windows. So Microsoft has built into the Windows, if you're connected by both, if you connect by wired networks as well as by wireless, it will use the wired networks, and the way it does is that by manipulating the weights on the routes. So the routing table is updated so that most of the routes is through the wired network. Okay. So similarly, basically 802.21 has policies that can be written down so that when it finds those networks, it decides which one to go next. Session continuity. It allows you to make before break, and then open interface for link state event reporting, for inter-system information service, and for handover service. And we are going to define those three services in a minute. So what is the link state? Basically, all these technologies that you have, whether it's 3, 11, 16, 3G, these are all links. These are all data links. These are all layer 2, right? Some of these layer 2 networks are up and some of these are down. That means they are not available, right? So your computer or your phone is now has multi-homed, is connected to multiple networks, and so we need to know the state of each of these links, and then we can decide how to connect you to the rest of the world, right? So that is the link state event reporting. Inter-system information service. And then if you have two systems available, 16 and 11, then you have to have some information be exchanged between those two. And then handover control, that's again, telling one system that I want to move and telling another system that I want to come. So this provides an architecture to enable low latency handover across multiple technologies, and it helps you in making your decision whether to move and where to move. And then it also gathers the network statistics, network characteristics. So it tells you what is available at what speed, and then there are commands for handing over, and then you can do both station initiated and network initiated handovers, both ways. Network can tell you to move over, or you can tell that I want to move over. What it doesn't do is that doesn't define the policy. So 802.21 doesn't tell you that you should be using Wi-Fi, then you have Wi-Fi and WiMAX. It's your choice, right? Those are your policies. It doesn't. It specifies the network. It doesn't specify a network selection procedure. So it doesn't tell you which network to use. Again, it's your choice. It doesn't execute the handover itself. Again, it's your choice whether you want to hand over. You want to execute the handover, and it doesn't tell you how to find out whether 802.16 is available or not. That's also again your procedure. So it does some things which are common, but it doesn't do something which are left to the consumer or the customer. So there are four concepts that we will use when we define the mechanisms. First is point of access. This is a general term for base station or access point, right? So each of these networks, such as 11 has an access point, 16 has a base station, 3G has a base station. Actually, they don't call it base station, they call something else, which we'll come to know when we talk about 3G. But those are the central points. Those are the points of attachment, points of access. Then the mobile node is what we call MS, the mobile subscriber. L2 trigger is the L2 event. So L2 is the layer 2, and if something happens in the layer 2, then that is called the trigger. Such as, for example, if you are driving and suddenly WiMAX becomes available, that would be an L2 trigger, right? So anything that any event in layer 2 that changes your connectivity is L2 trigger. Or if WiMAX goes away, then that's an L2 trigger too. And then the RATs are 11, 16, 15, whatever the technology we are using. So MIH has three services: event service, command service, and information service. Event is basically telling you the triggers. So it delivers the triggers and the events. When the link goes up, link comes down, or the new link becomes available, those are the triggers. And so the MIH module will basically come up, say, okay, WiMAX is available now. And then either your computer by itself or by your manual intervention will say, okay, now let's connect to WiMAX, right? So that is the event service. Command service is what you will use. So the set of standard commands for handover control. So for example, you say switch the link, configure the link, initiate the handover. Those are all the commands. And the information service is to get the information. So defines a service that provides information for fast handover. For example, the link of available networks, IP version numbers, network operator, etc. So this is where you just want to get the information about what is available. So for example, if 3G is available, you want to know 3G is from which operator. Is it AT&T, T-Mobile, and so on and so forth, right? So all that is information service. So there is information, trigger, and the command. Three of them, right? Trigger is actually is basically coming to you to, it's more like an interrupt, whereas command is what you do to change, and information is like DNS or something where you ask something, question, you get an answer. All right, so question, answer, interrupt, and action. Three parts. All right, so basically there are well-defined service access points, SAPs. So this is again the ISO terminology. So there are, what MIH standard has done, 802.21 has done, is define these service access point, which like define these subroutine calls. So you can go to any technology and make that subroutine call. For example, you can go to 16 and say, well, what base stations are available? Or you could go to 11 and say what access points are available. Now what 21 has done is defined a standard call which you can give to any technology. So that is technology independent. That is why it's called media independent handover. MIH is that the same call will work for all the technologies. And for that reason, all the technologies have been modified, have been updated. So for example, 11 has a new set of calls that it can accept now if you have a new 11, right, with that 802.21 implemented. So you might have a 802.21 enabled 11, or you might have a 802.21 older or legacy 11, right? Legacy 11 obviously will not work, with 802.21. So for 802.21 to work, you need the base stations and the customer devices that have the newer version of 11, 16, 3Z, and so on and so forth. Make sense? Right? So you might have WiMAX device. For example, my computer has WiMAX in it, but maybe it doesn't understand 21. Right? If it doesn't understand 21, 21 will not be able to help me. So MIH provides these services using well-defined service access points. Well-defined means every technology will understand exactly the same calls, same request. So here is where MIH fits in. It fits in between layer 2 and layer 3. So every device has a layer 2 and layer 3 in between. If you have 21, then MIH will be there, and when something happens, this layer is 802.21 aware, therefore it will tell MIH that this event has happened. Link has come up, link has gone down. And then MIH will tell layer 3 that this event has happened. Sometimes these events happen at different places, not in your device. For example, this might be a customer device, this might be a base station. Alright, or the other way around too. Anyway, so one device discovers that something has happened, and then it tells the other device that this has happened, and then it goes up. Right? So for example, the customer device might, here I am thinking about this is a customer device, this thinks that, oh, I have another WiMAX station available, I have a second base station available, so then it might tell the base station that, look, there is a base station available for me. Alright, so the event can flow vertically or they can go horizontally and then vertically. So these are the triggers. Triggers means link layer events. A link goes up, a link goes down, link is going down, so this is different than link down. Basically, whenever the system operators bring a system down, they tell you 15 minutes before that system is going down, right? Similarly, the network can announce that, okay, the network will not be available after 15 minutes, that is going down event, and at that point you can start taking action to move. Link detected, and then the link parameter change, And so basically link parameter could be, for example, the receive power changes significantly, so you could put a threshold, and if that happens then you will be informed. Link event rollback so these are events, I mean, which actually I am not sure whether this is link event rollback or link event rollback. I will have to check that particular one. Link SDU transmit status. SDU, anybody remembers what is SDU? Anybody knows what is SDU or PDU? So this is SDU is service data unit, PDU is the protocol data unit, right? So the link SDU transmit status. So when you give something to the link to transmit, that is link SDU. So it will tell you, that it is successfully transmitted that or not. Link handover is imminent, that I am going to move, and that the link handover is complete. I have already moved completely. All right. So why do you want to indicate that I am complete? Because you are connected to two towers, and both towers are sending you the same data. So you tell the old tower, now it is complete, I have already moved to the new tower. So then it will not anymore get or transmit the data for you. All right. So these are all the triggers. What this diagram shows is what the diagram is showing is two links, Ethernet and 11. So suddenly 11 comes up, and the Ethernet is going away. So you give the indication that I am going to switch the link, and then you go on to the 11. That's the kind of thing, right? It's showing us two different technologies. All right. So we talked about triggers. There are three things. Remember, there are three things it does: event service, command service, and information service. We just finished describing the event service. Now we're going to talk about the command service. So what are the commands? Commands flow from user to MIH to the link, and basically they allow you to switch the links, right? So it communicates with each technology, and then they don't go from one technology to the next. So basically there might be a layer, another layer 2 technology. So there's 11 and there might be another one, let's say 16. So you will have to send one command from layer 3 to MIH to 11, and another command from layer 3 to MIH to 16. To 11 you might say that I am disconnecting, to 16 you might say I am connecting, right? Like that. And basically each of these layers has been updated to understand these MIH commands. And they can go between the devices though. For example, you could tell your access point. So you will tell your MIH will tell the MIH at the access point, and the access point will tell its link layer. So just like before, they can go between the devices but not between the technologies. That's all there is about the command service. And we might see the list of commands. I don't have the list of commands here. So basically all we are saying is that the commands might be very similar to what we saw before already, is that switch the link or join the link or something like that, right? Disconnect the link and so on and so forth. Information service. So the last part is information service, and basically there is an information server to which you can send a request, and it will respond you with the information. and request might be, is WiMAX available at this location, and it might send you back, yeah, there are 2 WiMAX base stations transmitting at these frequencies, and then you can try to sense them, and so you can send the request from any technology to the server and get the answer back. So provides information about networks in a particular geographical area. Information delivery by queries are broadcast or multicast. So this doesn't have to be wired or wireless. It could be wireless, in which case it would just broadcast and keep telling everybody. Generally static information, so the information doesn't change. And 21 defines what information is required. So if you read 21 in detail, then it does have the database meaning. So whatever database basically element is, for each element there is a meaning assigned, so anybody can understand that meaning. But it doesn't define how the service is accessed. So it doesn't say whether you go by 11 or 3 or 15, but it does have the format of the request standardized. Alright, so when you say does not define how the service is accessed, the format is defined. So you know what request to send, but it doesn't say how do you access it. It's like this. When you do a DNS request, which is not this one, but DNS is similar, you make a request for the name to address translation. So it doesn't, IPA standard doesn't tell you how do you get to DNS, whether you get it by 11 or wireless or wired or something like that. It doesn't tell you that, but it does tell you how to ask a question. The question format is standard. Similarly, the information format is standard, the information request format is standard, answer format is standard, but how do you get there is depends upon how you want to get there. You might want to use 11, or you might want to use 3, or you might want to use both. That's your choice. All right. Common information representation, list of available networks. You can get location of each point of attachment. You will get the operator ID. You will get the roaming partners list. You will get the cost, security, quality of service, and you will get the capabilities of the network. Okay, so these are the things that you need to make your decision whether to switch. Now, if you want to see what we call the layer diagram, and this is how it works. This is layer 3, this is layer 2, right? Protocol stack, as we call it, right? Layer 3 and layer 2. Layer 3 and layer 2. So there is what we call logical link control, LLC, service access point, SAP. So each of the layer 2s have LLC SAPs defined. So when you use 11 or 3 or 16, there are certain services defined. So you want to transmit, you send a request, you make a service call saying that I want to transmit 1500 byte to this address. So that service call, that subroutine call is defined in the standard. So that is we call service access point. All right. But on the side, now there is MIH SAP. So now each of these technologies can talk MIH. And MIH has command, event, and information. Commands can be given to the link, event is a trigger, and information goes both ways. Right? This is what we talked about, right? Similarly, layer 3 can use this MIH SAP to be able to give command, get the event, and give or take the information. So these two new SAPs have been added. One is the MIH link SAP, which connects the MIH with the link, and there is MIH SAP, which connects the MIH with the layer 3. All right. So basically, the SAPs are how you get the service. So if layer 3 wants to get the service from MIH, it uses MIH SAP. and MIH wants to use the link, therefore there is a link SAP. And this is the old part. These already existed. Alright? Does this stack make sense? Right? What you had before was this layer vertical stack, and we did not explicitly list SAPs, but they were all there. Basically, if you read the standards, it will go through services, a list of services. So there are 4 or 5 or 6 or 7 things you can do with the layer, and so those are defined. That means basically what it is it's like a service, as I said, subroutine call. So they have defined a subroutine call, and they define the parameters that you can pass to those subroutines, and that's how you make use of that layer. Right? So these service access points, this is the old network, and now we have added these MIH extensions. Any question about this, or does it make sense? If it does not make sense, I can define it again. Does it make sense to you? Okay. All right. Makes sense? Okay. All right. So then we move. So how do we initiate a handover? Network initiated handover. So it's quite possible that the base station realizes that you are going on a road and you are going in this direction north, and therefore now you are 5 miles away. Maybe you will be better off if you were connected to the tower number 2. All right, and so that would be a network initiated handover, where the network will tell the tower number 2 that this car is coming or this phone is coming, and tell you, please switch. So MIH handover initiate suggests the point of attachment access, and then MIH handover prepare, and then MIH handover commits. These are actually the commands that we were talking about. I was just thinking where the commands are. So these are the commands. First command is handover initiate, second is handover prepare, third is handover commit, and fourth is handover complete. All right. When you get the initiate command, with that you get the base station's address, suggested POA, and then when you get the prepare, then you have decided and you are going to basically move to that network, and then the handover commit, the client commits to do the handover. He says, yep, I want to move, and then when it is done, it tells that I have moved, and now the new network to old network send all buffered packets. All the packets that have not been sent are sent to the new location now, and from there they will come to the client rather than coming from the old location, because old is now disconnected. So okay, if you forget any of the, if you need any of the acronyms, you have to go back to the end, and there is acronym right there. So MIHF is MIH function protocol. So MIH function protocol. So these are sent between the peer entities, and so basically these are the functions that we saw here in this diagram right here. This is the MIH function protocol. Communicates events, commands, information. So actually both vertical and the horizontal are the MIH functions protocol. So these are also MIH functions, the vertical ones and the horizontal ones. These are MAC independent messages which are defined in 802.21, and container for these messages are defined in each standard. So let me see what is container and what is a function. So, for example, if you want to find out what is the power of the Wi-Fi signal, right? So there is a 21 message which says 802.21 message which says what is the power of this signal, right? That's a standard. You can send it to anybody. You can send it to 16, you can send it to 11, you can send it to 3G. So that message is understood by all three, and that is defined in 21. But then 11, 16 and 3G people also have to get together and understand 21, right? So that is 11U. So there is a new standard called 11U which understands 21. So if your device is 11U compliant, that means it understands 21. All right. So there are two places where changes have to be made. Not only MIH alone cannot do everything. The standards have to be changed. So all the standards actually have been changed. Most of the standards. So 11U is there, 16G is there, and 3G might have its own, and 3 has its own. So even Ethernet standard has been changed. So all of these standards have been changed to understand 802.21 commands, or not commands, the messages, and commands as well actually. All right. So they understand the messages which include the events, triggers, the commands, and the information requests and responses. So they are defined in different standards. And then the transport is being defined in IETF. So the transport means sending the messages, and that means you may have to send it using IP and TCP, and so that is being defined in IETF. So how do you encapsulate a MIH function message? So basically all you need is an IP. Well, in IP you will have a TCP, but you will need a TCP port number or something to be able to distinguish a MIH function from some other protocol, right? So that is being defined actually or assigned in IETF, and that group is called MIHF. MIHF stands for Mobility for IP Performance Signaling and Handoff Optimization. So the MIHF group is working on implementing whatever is required from IP in terms of TCP/IP stack, let's say, not from IP alone, from the whole TCP/IP stack in terms of MIH. So these messages are transported by L2 or L3, and we already talked about L3. IP was L3, and that is what MIHF is doing. And if you want to send it over Ethernet or layer 2, then you use their standards, which is 11U, 16G, and so on and so forth. So all of these things are being defined, right? So 11U. In 11, the 11U is the modification for MIH, and so in the beacon it indicates that this access point is 21 capable, MIH capable. So the beacon, remember the beacon has several things in 802.11 beacon, actually every beacon, 16 beacon as well as 3G beacons. The beacons announce what is the access point ID and what are the things that, what are other things, like they might even indicate that this belongs to AT&T and so on and so forth, right? So those things also include MIH capability. And then there is a new entity called MAC Layer Management Entity, and so that has a SAP for link up indication and the scan confirm. So basically link up indication indicates that 11 is available when the event comes up, and scan confirm is that, you know, basically you scan the whole spectrum, all 14 channels or how many other channels you might have, and then and then you finish that, okay, this link is available or not available after finishing that, right? So those are the functions. Then they have for network selection, so there is an information service query frame. So there is a frame, there is a message that is understood by 11 now, and then it also has a transport for these messages over 11. If you want to send a message over 11 to base station or to other station, then there is a method defined. So these are all in 11U. So basically what 11 people have done is after the MIH was done, they made sure that the 11 understands all of those MIH messages and provides all the functionality. So that is what 11U is all about. Similarly 16 has done it too. I am not describing 16G, but 16G would be similar, and then 3G and so on and so forth. So that brings us to the end of this lecture, and the summary is 802.21 802.21 is a protocol for handover, initiation, network selection, and handover, and it defines a common interface to L3 for higher mobility and higher layer for mobility. It has three things. First, it has triggers, then it has commands, and then it has information service. All right. Now you understand what is a trigger, what is a command, what is information service, and now you know how you can move from WiMAX to Wi-Fi to back to WiMAX, and so on and so forth. And the way you do that is that MIH, those nodes have to be MIH enabled, and if you are MIH enabled, then you can ask questions whether, you know, what is available and what is not available, and then you can move. You have the commands. Okay. In terms of references, the best place to start is a paper written by another student in 2006. So this is about 4 years old now though, but just like you are writing papers, somebody in 2006, this was all very new stuff. Actually it didn't even exist at that time. In terms of the latest stuff, there is a paper in IEEE Communication magazine which is available online, and then there is a standard. Standard is done. Standard is dated 2008. Standard is also available free to anybody who wants it at this URL. There is a tutorial slide available on 21 from the chair of the group, and these are other documents. Okay. Wait a minute. This continues. Okay, so more and more material, tutorial materials. Plenty of material on 21. 21 is all done, so now it is available. It's not a problem. There are Wikipedia articles, soft handover, vertical handover, handoff, roaming, media independent handover, and 802.21. So the homework says read the standard, make a diagram showing the general MIH reference model showing the exchange of MIH information and messages with remote MIH function. Now, I think I might leave that homework for you to do actually, because you do have to read one standard, and this is only 323 pages long. However, you don't have to read the whole standard. You do have to read the table of contents and then go to the right page, and you have to find out as to how to get these standards. So that's the whole exercise, because this will take you to get to the standard, how you get all these standards, IEEE standards, and that's the process I want you to go through, that process, right? So you get the standard, look at the table of contents, find the answer to this question, all right, which is a very simple diagram. So once you find the standard, this is not going to take too much time. Okay, so So while 13 is not due, 14 is due. All right, for 13 I am going to find a replacement, and the reason is that the standard is not available. See, my problem with 13 was that the standard is in works, is still not completed. So I could not give you a standard, and I could not, so this one at least you have the standard accessibility. And so you might just get that exercise done.
What do you mean by diagram? Like a table or?
Okay, so make a diagram showing reference model showing the exchange of information exchange with the remote MIHF, with messages with the remote MIHF, right? So the diagram would be very much like this combination of this here and this. Okay. All right. Any question about 21? Yeah.
So the MAC layer management entity thing, the source access point, is that the same thing on the diagram as like these MIH link SAPs for just for?
Okay. So are you on this slide?
Yeah, but I'm saying to the left of each network, right? You have an MIH link SAP. Is that basically that is the MAC thing for the 802.11u standard?
Yes, right. So this one will go into 802.11u. If this was 16, that will go into 16g. Yeah.
Okay.
Right. However, I mean, these are all standard in the sense that they are all basically you can give the same command to 16 and to the 11, right? So the standard method is defined here in this 802.21.
I guess I'm specifically asking though, the MAC layer management entity, is the part of that
that is part of 11, yeah. So that is, okay, so 11 people define that MLME thing, and you will find that in 11, U. Is that the question?
Not really, I was just saying, something acts as that MIH link SAP, is that a part of 11U that acts as that? Or is it just 11U as a whole then?
Okay, all right, let me explain that, okay. So the 11U defines many services, okay. An example of a service is, and this is why I want you to read the standard, because when you go to the standard you will find all these services. So one service could be, for example, I remember from, and I'm going to take a different example because I don't know 11U, but basically right now. So in 3, okay, 802.3, which is simply Ethernet standard. So there is a service called transmit. A parameter for that, first parameter is packet. Second parameter is packet length. Third parameter is packet destination. All right. So that's like a subroutine call. So that is one service. That is one service access point, you can call it, right? Another one is receive. Right? Another one might be, I don't know what else. I mean, so there are these services defined. So each service is like a subroutine call. So does that answer your question? So 11U has many SAPs.
Okay. Yeah.
Okay. So that's what it is. Okay. For each service, basically there is a subroutine call defined, and so that is what we call service access point. All right, so having done this, we have some time, and I'm going to use that time to actually do something different. So let me just see if I can stop recording this.